So now we're moving on to section 8, where we're going to talk about the role of the liver. And collectively, some of the functions of the liver include metabolism, storage, and detoxification. The liver is actually able to process nearly every type of class of nutrients that we have, along with playing a huge role in regulating our plasma cholesterol levels. It's also capable of storing vitamins and minerals, and detoxification wise, capable of metabolizing alcohol, drugs, and bilirubin. So, again, we have more than about 500 metabolic functions of the liver. I don't expect you to know the specific functions in this table, but they're here for your reference if you would like to look at it. We will mention some of these, but again, I wouldn't necessarily study this table. The big thing to take away here are the major metabolic processes that the liver is targeted for. So, carbohydrate metabolism, fat metabolism, protein metabolism, vitamin and mineral storage, and biotransformation functions are all roles of the liver. So let's start with cholesterol metabolism. So we don't use cholesterol as an energy source. We do, however, use cholesterol as a structural component of things like bile salts, steroid hormones, and vitamin D. It's also a huge component of plasma membranes, making up about 20%. Most of the cholesterol that we need, actually, we have to synthesize ourselves. We only get about 15% of the blood cholesterol from our diet or whatever we're bringing in. We also lose some cholesterol as we break it down, and it's secreted into bile salts, which eventually are going to be excreted into the feces. When we're talking about cholesterol transport, we have to keep in mind that both triglycerides and cholesterol are insoluble in water. So because of that, they cannot circulate freely in our blood. They have to be transported to and from the tissues, bound to something else. And they're bound to small lipid protein complexes that we call lipoproteins. And these complexes make those hydrophobic lipids soluble, and they also have signals that help regulate their entry into and out of different cells. And when we're talking about lipoproteins, they do vary in the fat to protein composition, but they all contain triglycerides, phospholipids, and cholesterol in addition to protein. In general, the higher the amount of lipid in the lipoprotein, the lower the density, and the greater proportion of protein there is, the higher the density. So on this basis of density, there are very low density lipoproteins, or VLDLs, low density lipoproteins, or LDLs, and high density lipoproteins, or HDLs. And we already talked about chylomicrons before. These are used to transport lipids from our gastrointestinal tract, and these are going to have the lowest density of all, meaning they have the highest proportion or percentage of lipid in the lipoprotein. So I would have a general understanding of all these transport vesicles that we are using for cholesterol and lipids. So, for example, if we're talking about a chylomicron, what its function is basically to help transport the lipids from our gastrointestinal tract to the liver. Our VLDLs, these carry triglycerides from the liver and send them mostly to adipose tissue. Our LDLs carry cholesterol from the liver to the tissues, and our HDLs carry cholesterol from our tissues to the liver. Okay, so we do have recommended total cholesterol, HDL levels, and LD levels. A total cholesterol level typically below 200 milligrams per deciliter of blood is generally considered to be really, really good. If we have blood cholesterol levels greater than 200 milligrams per deciliter, these have been linked to different things. So, for example, atherosclerosis, which is going to clog arteries and could potentially cause strokes and heart attacks. So when we're talking about cholesterol from a clinical standpoint, there are some different things. HDL is thought to protect against heart disease because it takes that cholesterol out of the blood. So typically, if it's greater than 60 is good, lower than 40 is not good. Our LDLs are generally considered bad, so think L for lousy, and HDLs, the H, think for healthy. So our LDLs can become the deposits where we're going to put cholesterol into like artery walls. So we really don't want too much. So 100 or less is going to be good, and 130 and above is not very good at all. So we do have some factors that help with regulating our blood cholesterol levels. So our liver is going to be responsible for producing cholesterol at what we refer to as a basal level. So kind of like a baseline, regardless of how much cholesterol we are actually bringing in from our diet. So if we have a restricting diet, if we restrict cholesterol in our diet, that does not markedly reduce blood cholesterol levels because we are producing it at basal levels. More important effect is the relative amounts of both saturated and unsaturated fatty acids that we have in the diet. So these do have an important effect on blood cholesterol levels. If we have a huge amount of saturated fatty acids in our diet, this stimulates our liver to synthesize cholesterol, and it also inhibits excretion from the body. If we're talking about unsaturated fatty acids, so things like olive oil or vegetable oils, if they're liquids at room temperature, these will actually enhance excretion of cholesterol as well as its breakdown into bile salts and help lower our total cholesterol levels. We also have trans fats, and these are made from what we consider healthy oils, and they have been hydrogenated, meaning hydrogens have been added. So they're not naturally occurring. And when we go in and hydrogenate them, we make them more solid. So something like a margarine. Trans fats typically have a negative effect on blood cholesterol levels, worse than actually our saturated fats do. And when they're talking about the trans and the fats, they're just referring to the orientation of hydrogens on adjacent carbons. We also have unsaturated omega-3 fatty acids that can be found in some cold water fish, so things like salmon, and these can help lower the proportions of both our saturated fats as well as cholesterol. The function of the omega-3 fatty acids is really to help make our blood platelets less sticky. So it's going to help prevent spontaneous clotting that can lead to blockage of blood vessels. And it's thought that they can help lower blood pressure as well. So if we have a good amount of aerobic exercise as well as estrogen, these can increase our HDL levels, remember H for healthy, and decrease our LDL levels, L for lousy. So aerobic exercise can help increase our healthy cholesterol and lower the bad cholesterol. Clinically, it was thought that high cholesterol and LDL to HDL ratios were considered the most valid predictors of risk for all types of diseases like atherosclerosis, cardiovascular disease, as well as heart attacks. Almost half of those who actually get some sort of heart disease end up having normal cholesterol levels, while others with poor lipid profiles actually remain free of heart problems. So this isn't necessarily what was originally thought. So now they think that the LDL levels and other risk factors are actually to believe to be the actual cause of these different diseases. So if we do have high LDL levels, there are some treatments that we can use. Some cholesterol lowering drugs such as statins. Those can be prescribed to people who have high LDL levels. And it's actually estimated, if we're talking about the United States, that more than 10 million people are actually taking statins.